Okay, so Friday we talked about, does anyone remember?
Float chamber?
Float chamber. Nope. Come on, somebody's got it.
Carburetors.
Yes.
Speed and idle mixture.
That is correct. How to set the idle speed and idle mixture. So we went off track Friday, but now we're going to go back on track. So if we go back to Thursday, we were talking about float chambers. And I'd already written this down. Float chambers. 1, acts as a reservoir for the fuel to be used, controls the level of fuel to discharge nozzle. What happens if the float level is too high? The fuel level. It's the fuel level. We call it the float level.
Run rich.
It runs rich. What else happens?
Whenever it's turned off, fuel just dumped out.
Yep. Because the needle is also needle seat are also supposed to shut off fuel from running out the nozzle because the fuel level should be where?
Below.
Just below the output of the nozzle. So that's how you know. So if I say, hey, where should the fuel level be? You say, well, right below the level of the nozzle. Right? Okay, let's see. And fuel enters the float chamber from the fuel supply. What is my fuel supply?
The tank,
That's right. And where are the tanks often located?
the wings.
The wings. And sometimes we have high wings and low wings, right? So if it's...
Most of the time, unless they're like in the DV20, they're right behind the.
Oh, that's true. Yeah. Okay, so the Aeronca right there, it actually has it behind the instrument panel. Let's see, a Cub has it also up front, and sometimes the second one in the wing. So yeah, a lot of times they're located around the fuselage, especially these old planes that have gravity feed. All right, so if it is a high wing, or it is an older aircraft like the Cub or the Aeronca Chief or something like that, it doesn't usually have a fuel pump if it's got a carburetor. So it just has gravity feed. So gravity feed systems, we have gravity feed. So gravity feed systems, they're going to run about 3 to 5 PSI max if you can get it out of it. And does anybody know the term for that? If you have some sort of,
The head.
that's it, yeah, head pressure.
Huh.
So when you have a cold or something, you have that, they say you have a lot of head pressure. That's what it's referred. It's about 3 to 5 PSI, and that's where they get that from.
No way.
Yeah. Yeah. Now, if you have a low wing, that doesn't work so well because the fuel's already about the same height as the carburetor. So you have to have a fuel pump. And then if you need fuel pump, you need 2 fuel pumps because if you have 1 fuel pump and that fuel pump quits, what happens to the airplane? It also quits. So pressure systems found on low wings is about 5 to 20 PSI. All right, so I'll tell you about fuel metering force. And the definition is going to come out of this book, Aircraft Fuel Metering Systems. This is the book where I keep saying, wow, there's a lot of information. It's really good. So I recommend it. There's copies in the tool room, in Canvas. Okay, so according to them, remember we had this conversation where I said, I'd really like to call fuel metering force the distance that the fuel actually has to go to reach the nozzle. So in a way, that's exactly what they said, but then they make it a little more complicated. If I can find it real quick. I need the crickets. Here we go. Let's see. The difference between the height the fuel rises in the discharge nozzle with no airflow and the edge of the nozzle is very critical, and the force required to lift this distance is known as the fuel metering force. So while I wanted to say it's the distance, they talk about the distance, but then say, oh no, the amount of force required to raise the fuel from the fuel level to the discharge nozzle. So we have a discharge nozzle. Has little holes in it. And the fuel level's right here. So between here and here, they say fuel metering force is what is required to raise the fuel that high. So it and so what is actually the force required to raise the fuel that high? Where do we get this force? Okay, so we have the Venturi. Venturi is half of it. So the pressure created the Venturi, and what else?
The cylinder section?
No,
I guess.
the
Not cylinder
pressure-
suction.
Head pressure?
The pressure pushing down on the fuel in the chamber.
What chamber?
The flow chamber.
Float chamber. So it's the difference between the pressure here and the float chamber. What if those two pressures are equal?
No fuel.
No fuel comes out. So thus we go back to the back suction mixture control theory. If we add suction that is equal to this to the float chamber, how much fuel comes out of here? None. Okay, so so the fuel metering force then, according to this, is the difference in pressure from the float bowl to the Venturi. Or we could say the force required to lift the fuel from its normal normal level to the discharge point. All right, main air bleed. So our messy carburetor here, that looks terrible. All right, so we have the main air bleed we created right here. Should I stop using that? Let's start using, perhaps, let's see, where's my Stromberg? Oh, it's in that order. Yes, maybe this is a better one to look at. Okay, so the Stromberg, so right here is our main air bleed. And so we're going to talk about the main air bleed. These are a little more difficult because they don't always show everything as well. Yep, and that's just way messy. Okay. Not messy, just hard to read. Back to here. So main air bleed. So we're going to talk about the main air bleed. What does the main air bleed do? I'm looking for some suggestions here. What? It bleeds air. Off of which stage of the compressor? Which compressor stage? Wrong class. Okay. Into. Give you a hint. Helps. Helps do what?
Emulsify.
What?
Emulsify.
So it emulsifies the fuel. What does emulsifying mean?
The premixes just a little bit of air, so it atomizes it easier.
Okay, so it adds a little bit of air. So there's a huge distinction when we talk about a little bit of air. So if we're talking about, say, the idle circuit, well, that'd be we're talking about the main bleed air, so I'll stick with that. So we're talking about the main air bleed. Let's some air in. So it's a very small amount. So what's the stoichiometric mixture?
15 to 1.
15 to 1. How much of this air plays into the 15 part?
0.
Yeah, it's about right. So just to round it. Okay, so we can't really count that, so make sure we know that. But it helps break surface. Whoa. Because I need to just disable those buttons. Helps break surface tension. The liquid of fuel, because it's liquid. All right, so without that, the fuel doesn't want to come out of the nozzle so well. All right, we back? We're back. Okay, helps break the surface tension of the fuel. Helps. Then it helps lift fuel to the discharge point. Helps provide a more uniform mixture of fuel and air.
That's kind of indirectly, right?
Um,
Because it causes bubbles,
it does.
and the bubbles are what's breaking up the surface tension.
Yes.
So if they come to the nozzle, it's going to make it easier to mix later.
Yes.
Not now. Like,
Correct. Yeah. It is just the whole thing. Yeah. Good point. Whole thing works too. What else do we have here?
Acceleration reserve.
Nope. Does not do that. Creates a place for that.
Yeah.
Place for it. But when it's operating, no, it creates. What do I say? Creates more surface area. Of the fuel for faster evaporation. So when we have the fuel breaking up into smaller droplets, there's more of these little droplets, which means there's more surface area of the fuel, right? Because it's a difference of like one big globule fuel versus hundreds of little ones. There's more surface area, and you have more surface area, and you get faster evaporation. Let's see. What happens if the air bleed is blocked?
Runs rich. Lean. Well,
I think I want to go with the Q&A answer. And what does the Q&A answer say? Goes rich. So more suction is acting on the discharge nozzle. So more fuel will be drawn out in larger, less precise globules with less air. This would be a rich mixture. What happens if we'll make the air bleed too large? What do you think is going to happen? I'm going to get too much what now?
Air.
Yep, too much air. Causing a lean mixture. Main metering jet. What do you think that is now? It's at the bottom. What is it for?
meter fuel.
Its job is to meter fuel. When is it going to actually do its metering?
When the fuel's at the proper level.
Okay, when fuel's at proper level. That's true. Above idle, for sure. Whenever we have an orifice and a flow through that orifice, when does the orifice do most of its real restricting? It's designed.
Full throttle.
There you go. That's kind of what I'm looking for. So if you have to think about if you're going to design that orifice, are you going to design it to accurately meter fuel at wide open throttle, part throttle. You know, you kind of think about that. Well, if I made it the right size for part throttle perfectly, then what happens when I go to full throttle?
It's not enough.
Then it's not enough. So it's got to be based upon full throttle operation. So main metering jet. It is a calibrated orifice. That meters fuel accurately. Of course, based on the pressure differential. Between fuel bowl and venturi. We have our float mechanism. What does my float mechanism do? That's exactly it. Controls the level of fuel in the bowl. And we already said, where's the level supposed to be? Level should be just below discharge nozzle outlet. What makes up the float mechanism?
Fulcrum, float, and
I'll get 3 parts. How about that? Part number 1.
a float.
Float. What else?
A fulcrum.
Fulcrum's built into it.
Hinge.
The hinge is the fulcrum. It's kind of built into it.
Needle.
Needle. I hear needle. Somebody say needle? The needle and the seat. I will tell you there's been a lot of problems, especially with the seats over the years. And they've been made out of different stuff. They were, I think, made out of a rubber. And then when they changed fuels, the rubber would get soft and it wasn't working well. I don't remember which way it went. I think they tried one that was, it's called Delrin or Delron. It's like a white plastic. And that didn't work. And then there was just a plain steel one. I think the plain steel one was kind of, maybe they went plain steel. Then they tried the rubber, which didn't work. Then they tried the Delrin, which had problems. So guess which one they...
Steel.
Yeah, they went to steel. So guess what? The problem with steel is it doesn't really want to seat that well into the seat. You can try and burnish it in a little bit, but it doesn't. So it's especially problematic with and I'm talking about the Strombergs, and they're just a problematic carburetor for that reason. So if you have a Stromberg carburetor on your airplane, you just get used to turning the fuel off when you're done with the airplane, because what's going to happen as it leaks out of the little needle and seat? The fuel. What happens?
It's gonna fill up the
Force
float.
the carburetor.
Yeah, it
Gonna fill
float
up-
level goes up just a little tiny bit. Then what happens?
Then it's gonna go over the,
Out of the discharge line.
yeah.
Out of the main discharge nozzle. And as how would a person know that we have this problem?
So leaking carbon.
So you have a leak in the carburetor. How can you identify a leaky carburetor?
Look underneath the nose, and there's
There's stains.
a fuel puddle.
Now, you won't have a fuel puddle. You'll have
Stains.
blue stains.
Okay.
So aviation fuel does a pretty nice job of evaporating, but the one thing that doesn't evaporate is the blue dye. So you always look for your tattletale blue dyes. Wherever you have blue dye, don't just kind of dismiss it as, wonder why there's somebody dropped their Sharpie. You have a leak. Yeah.
Why does it not stain stuff in its liquid? Is there just not enough dye?
I don't know. Probably, yeah, there's not enough dye. It just gets concentrated, and then the fuel evaporates and then leaves the dye ring there. So, all right, so we have all that. Let's see.
Is there a lot of wear on the seat? Like, why would you need it made of steel? If they tried rubber and it was just too soft, why not?
It's not that it was too soft. It's the fuel attacks it, and it's prone to deterioration.
But fuel-safe plastic, like, wouldn't that be?
There's no such thing. I don't know. I'm just making that up. But think about the fact. Okay, so what does it take? So let's just say that you had 100% guaranteed fuel-safe plastic. There's no ifs, ands, or buts about this, and you're like, this would work, and everybody goes, yeah, it would work. So what do you have to do that? Got to get it approved. And are you going to do that? No, it's going to cost you, $100,000 to get it approved. And what if it doesn't one day? What if during your manufacturing there was a flaw that caused a little crack somewhere and that needle broke? And so then what happens to the airplane when the needle breaks?
Get no fuel.
Get no fuel, and then the
Engine stops.
And then the plane crashes into a busload of orphans and nuns on the way to rehabilitate wildlife that was injured in a oil spill. And so then you get that. Is that about worst case scenario?
What is the needle made of?
Steel.
It has some kind of plastic or something around.
Do you have a little black on the end? Okay, that's the rubber. And that's what I was saying. They've changed those, I think, now to all steel.
So it's steel on steel.
The seat's a little brass.
Oh, okay.
So it doesn't seal well. So you get a little bit of leakage, but that's the worst you get. So
That's good.
fuel level is critical. If the fuel level or float level, same thing. If I say fuel level, float level, it's synonymous. If it's too low, what happens?
Won't be discharged.
It won't be, well, let's just say it's just a little bit too low.
It's lean.
You're going to run lean. Why is it going to run lean?
Well, because
Because
it
it'll
has
take
to
more pressure to
Getting
pull it out.
So we could say we need more fuel metering force to get it out, which I would have liked to say air metering force, but so it's going to run lean. If it's too rich, yeah, that's what I wanted to write there. Too rich equals too high, so too high
Too rich.
equals rich. Why? Because of the opposite reason there. Measuring fuel level. So when you are working on carburetors, it's critical that you check this fuel level. And most of you have already experimented with the Stromberg. And you take 3 readings, and how many of you guys have done this so far? And of those 3 readings, how many were exactly the same?
2.
You had 2 exactly the same? Yeah, you cheated. All right, but the nice thing is you can actually check the Stromberg, and you take a bunch of readings because it never is the same thing twice usually, unless you cheat. Let me see here. Do I have a picture of doing this? I thought I do. I don't. We'll go with this one. What's missing here?
The float.
The float. I don't know how we're gonna work.
Looks pretty murky too.
Yeah, I know. It's probably water down there.
Yeah.
That looks nasty, actually.
Yeah, that looks pretty bad.
It's probably been sitting for a while.
Well, since we brought this up, we'll mention a few things here out of order. So number 1, we're going to set the fuel level. And what happens, we don't need to do that. Let's go back here. All right, so we have our fuel bowl. And in it we have our fuel. I need to change my colors. So we have our fuel. And fuel doesn't just lay flat in here. When it gets near the edge, it climbs up. It calls meniscus. So it wants to climb up. And when you're checking the fuel level, what you're going to do is you're going to put on the carburetor bench, and you're going to let the fuel come in, and right away you're going to take a reading. Why do I want to take it right away? Not wait a little bit.
Because it could be leaky.
Yeah, it's going to leak and just keep going. So you wait long enough, it's going to be up here. So don't wait too long. And so you're going to take your depth gauge, and has a little pin that comes down. So you're going to set this all the way across, and you're going to measure this. And as you get down here to the surface, you're going to come down a little bit more, a little bit more, a little bit more, and right about the time you get right next to the surface,
Same happens.
you're going to go bam, and this is just going to, fuel's just going to jump up on there. It's just all of a sudden, whoosh, fuel goes up. And now it looks like this needle is halfway under the fuel, right? But it's not. It just jumped up on it. So that's your correct reading. Stop, take a reading, do it 3 times. All right, and it's easier to do. You can do this on the Stromberg because of the way it's built. The float and the bottom are all together. The Stromberg, yes. The Marvel Shoveler is the opposite, and the bowl is in one half, and you have the other half, and the floats are over here. So floats go inside, so you can't do it on that one, but you can on this one. So Stromberg is because the float is in the lower half. It's actually tested with solvent at a specific what's the word I'm looking for? Specific gravity at a specific gravity. That did not make sense, but a called out specific gravity, and specific gravity and head pressure. Yes.
So for the 3 readings, do you drain the solvent out and then refill it and start the whole process over? Or do you just do the needle 3 times?
No, you gotta get rid of the fuel and bring it back up. Dump it out. At least drop it down so the float engages again. Because it would not make sense just to run it down, check it, wipe it, run it down, check it, wipe it, run it down. That's just testing you. You need to check the fuel coming up 3 times. Did you do that? So you did cheat. I knew it.
No wonder it was the same.
I know. Yeah, it's the same. Jeez. Because what you're doing is you're testing the accuracy and the shut off of the float to make sure it does it the same. It's repeatability. Let's see. Yeah, now it makes sense. Remind me to give you -1. Yeah. Always measure away from the edge. Why? Because it's raised up here on the corner. So you measure it here, you're going to get a false reading. That would be as crazy as just sticking this in 3 times without changing the... But who would do that? How do we adjust it? Adjustment of the fuel level.
Gaskets and washers.
Washers underneath the seat.
Yep. By raising
The 1-to-5 ratio.
or lowering the seat. All right, so to raise the fuel level, what am I going to do with the seat?
Put a little shims underneath.
Let's see. So we have the needle. And then we have a seat. Threads on it, holes. And let's see. And then we have the float on an arm. And little fulcrum right there. Did I get it? Okay, so Fuel level's right here. Well, so I want the fuel level. Well, I measure it, and the number I measure is too big. What does that mean then?
It's too
Too low. So remember, you're measuring things backwards. It's not backwards. It's just what you're doing. So if this is the top of the top, and it gives you a dimension, it should say right here it's 0.40625, which happens to be 1330 seconds. That's what it should be. But I measure it, and I end up getting 0.412. Is my float level too high or too low? I got a bigger number, so that means that it was 412, means it's too low. So I need to raise it. So in order to raise this level, that means that this should shut off later. So in order for it to shut off later, would I want this seat to be up here or this seat to be down here? Down. Okay, so what I'll do is you'll actually unscrew this, take it out, and change the shims below. So to raise the fuel level, you lower the seat. To lower the fuel level, raise the seat. How much do I raise and lower the seat?
5 to 1.
Well, this is not the way I kind of drawn it. It might be linear, but it's actually the fulcrum's about over here. And so that means that it's not linear at all. So for every 1/64, I move the seat. So move seat. The fuel level change is 5/64, which is to say there's a ratio. And what is the ratio?
5 to
1 to 5 or 5 to 1 is more appropriately stated. So for every 1 that I move it over here, I'm going to change the fuel level 5. So if I were to come back to, well, I had these numbers right here. So what's the difference between those two? You're going to make me do it, aren't you? So, point. So the difference between those is 0.575? 0.0575. 0.0. So that's the difference. So should I change the seat 0.575? Nope. I need to change it 1/5 of that. So simply divide by 5, and you will end up with 0.115. That's the size shim that I should put in there. Now I know the book talks about 64ths and 30 seconds, and a lot of you guys are kind of making it a little more difficult when you're trying to figure out how many 64ths that is. Just give me an answer like that. It's 0.0115. Because honestly, when you buy these shims and you have they come in all different sizes. They're not stuck to just 64ths and 30 seconds. It's pretty fat. So you want to get in there, and there are minor adjustments. You can get a shim that's maybe not quite. Yeah, that's quite a thick shim right there. So you can get some that are down to thousandths or so. So that's totally reasonable. All right.
So I guess with a shim you get as close as possible, right?
Yep.
Mhm.
Why isn't it like done with Seth group?
Well, they don't want anybody just doing it, right? I don't know.
What was the question?
Why don't they just make a set screw that you can just adjust it in and out? Or why don't they just do like a Marvel where you can just bend a little tab, you know? No, just not the way they did it. All right, so that's a Stromberg. So the Marvel float is measured while it's dry. Why? Because the float is not connected to the float chamber. They are separated, so you can't really put it together. If you did put it together, then it's not, you're going to do a second check, but it's measured dry. And I'll let you look at basically what you're going to do is you actually just turn it upside down. The floats fall, and you use a little drill bit, and it shows you in the manual how to measure it with just a drill bit, just near the edge of the float. It's not a real accurate thing. I mean, it's crazy how accurate the Stromberg is. Then you get into Marvel, it's like, put a drill bit near the edge of the floats. Now it's a little easier because the floats are very square, but they used to not be square. They were rounded on the corners. So it was like put it near the edge, which was rounded, and you come up with something. And, it'll work. And they did. So, and then float is measured dry. Fuel level is checked with a sight glass. So what you'll do is you'll actually assemble the entire carburetor, and then you're going to put a little, so you'll have let's draw the bowl. You're actually going to take a little fitting and you're going to put a piece of clear plastic, and you'll be able to see in the clear plastic where the fuel level comes up to and measure it, and it'll match right here.
That's kind
Is that what that extra port
of
is for?
simple.
Huh?
Is that what that extra port is for?
Okay, so what? Yes and no. So what is this extra port for right here? Well, number one, number two, you can put a sight glass. Number one, see all that nastiness down there?
Like drain it out?
It's disgusting. And the only way you're going to get that out is to take the carburetor off and take it apart and turn it upside down, except that right down in here, there's a little drain. So there's always going to be a drain on the bottom of the carburetor that I highly recommend taking it out every annual and draining out whatever's in there, because you can get some nasty water down there, and that water will start corroding the inside of the carburetor, and you don't want that. So, and adjustment. Adjustments are made by bending the float tab. There's just a little tab on the float arm. You just bend it. All right. Never check needle and seat with shop air. And that's not in your book. Everything I've ever really broken well in aviation always started out with, you know what, I bet shop air would work on that. So there's two lessons right here for you. One, don't use shop air on a checking a carburetor. Number two, and I've said this before, when troubleshooting something, it's just our nature. We're thinking about it. We're stuck. We're like, oh, I'm trying to think of an idea. And so somebody walks by and you're like, hey, Tim, I'm having a problem with the carburetor. What do you, the engine won't run right. What do you think it is? And Tim, he's got his own thing going, and he's always working on his airplane over here. He's got his mind in it, and he's just going to look at me and go, I don't know, maybe your fuel's not getting through your needle seat or something. Oh, that's a good idea. How should I check it? And he's like, I just blow some air through it or something. I don't know, man. I'm doing my own thing, right? So this kind of happened, but it was in the inverse. So, I'm doing my own thing, and we had an airplane, and it wasn't my engine. It was somebody else overhauled the engine in our shop, and he did the mags, and he did the carburetor. And we'd start it up, and this thing would just take off, and it would just kind of go, higher RPM and die. So every time we started, high RPM, die. Couldn't get anything out of it. Well, what does that sound like right there? Does it sound like so whenever you're doing troubleshooting, you can break it down into fuel, air, mechanical, and spark. So 4 things: fuel, spark, air, mechanical. So number one, the easiest, is it getting air?
Yes.
Yeah.
Okay, well, you got to look. Is the air filter open? Is it getting air? Okay. Spark, is it getting spark?
Yeah.
Well, it sounds like it. It's starting and it's going up to high RPM and then dying. So it's air, spark, fuel. Does it sound like it's running out of fuel possibly?
Yeah.
Okay, it's either running out of fuel or running out of air, or suddenly the spark is quitting for some unknown reason, which doesn't make sense. So, or mechanical. Mechanical would be something like you mistimed the internal of the engine, you have a stuck valve, something like that. So, basic troubleshooting, it always comes down to those four things. So, you know, we're targeting in on, okay, it's a fresh overhaul. Of course, what does everybody say first thing?
Timing's off.
Oh, sure, you misadjusted the timing. Okay, so no, that's not it. But of course, everybody did say that. And so, zeroed in on the carburetor, and it made the most sense. And I'm very busy doing something, and they've been working on it all day or something. It's like, what do you think it could be? And I'm like, well, it sounds like it's running out of fuel. I don't know. I mean, is the float bowl filling up, and then you're starting it, and then the float bowl is being drained out, and no fuel is getting back in? Like maybe the float is stuck, and because it could do that, the float could hit the wall, and just to allow a little bit of fuel. So over time, it fills up the fuel bowl. Now you start the engine, and sucks the fuel bowl dry, and the engine quits, and it slowly starts filling up. Does this make sense? It should, because that's a real possibility. So hey, maybe it's doing that. Well, how do we know? I don't know. I guess you could just blow some air into it or something and see, the passages are working. If you disconnect the fuel line and blew shop air into the fuel line, what would happen? Not the fuel line going back to tank, but through the carburetor.
Seat would blow out. Rubber part.
It would go through, and no matter where the float was, it would probably have enough force. It would force the needle off the seat. It would pressurize the float chamber, right? And in theory, it could force the fuel down and out the carburetor because you're putting enough fuel on there. Training aids here.
Basically, you destroyed the carburetor, so the seat floats.
Well, unfortunately, I don't have my whole Redwood out here. Listening at home, you won't be able to see this, but carburetors have gone through several different versions of floats, but this is the pretty much common float when I was working in aviation. What are they made out of?
Brass.
Super light. I mean, look, if somebody held it too tight. In fact, sometimes you can heat them up with your hands enough to start warming that air up, and you can actually pop dents out of it. So that's how thin they are. So this is in there, and sure enough, blew it through, went in, pressurized the chamber, and in theory, it could have pushed the fuel out the main metering jet, right?
Yeah.
Fuel doesn't move that fast. Well, then it didn't work at all anymore. So you took apart the carburetor, and let me tell you, these things were as flat as a piece of paper. It was the funniest thing I ever saw. Like, ooh. I shouldn't have done that with the shop air. So it will flatten those floats instantly and prove nothing. So don't use shop air.
So you guys had to get a whole new carburetor or just a whole new float?
They had to get a whole new float. And, well, I guess you probably want to know what happened. This must have been now that I think about it, I want to say it was a HA6, a horizontal because of the engine, but it must have been a larger MA4-5, which really isn't we have some. You guys may do that project if you get done. But the MA4-5, I can't even draw it. So the Venturi is going to go here. And it looks a lot like this. And so this is the outside of the carburetor here, and here's the outside here. But you have this chamber right here. And this chamber has a bushing here, and a bushing here, and another bushing here. And that allows the throttle shaft to go through here. So the throttle shaft has to pass through 3 bushings. This air right here has a lot to do with the mixture control. And in fact, it's got a needle valve, a second needle valve that it controls the air pressure inside of here, which then controls the air pressure on top of the the float chamber. And what had happened is the mechanic missed an O-ring. I don't remember if it was this O-ring or this O-ring. And it really matters because this O-ring here will always allow air to get sucked in. I think this O-ring allows air to get blown this way, and this one allows air to go in this way. So all these different paths can happen with the wrong O-ring. And one was left out, and so what was happening is it just had a massive air leak into it. And so whenever we started it up, it just sucked a bunch of air and not enough fuel and then died. So let's see if we can finish this off real quick. Yeah, we'll go 6. Yep, that's it. So we'll take a break.